A couple of days ago, I received my very first FPGA. I've been wanting to build my own CPU for quite some time. I find it very exciting, and since I'm already writing a kernel and it'll soon become an operating system pretty much, since it'll have user space, so collectively an operating system, I at least that's how I call it. I thought like, okay, let's go a step further. I don't like many things that x86 does, and I feel like um, I could build something that would work for me, for my purposes better. Doesn't mean that it would work for anybody else or that it would necessarily be better, but for me, I just want to build it my own way. So I thought that an FPGA would be the best way to get started. So I started with a simple like hello world equivalent, just controlling LEDs with switches, and then I decided to just start. So I started designing a core. I specified a very basic, for now, like revision 0.1.0 ISA for it. I call it the minimal instruction set computer, MISC, because we have CISC, RISC, and I'm not aware of MISC, so I decided like, hey, let's call it MISC, very minimal. Only 15 instructions, 8 registers. So I implemented the register file with 8 registers right now. It's still very basic, like I said, but I want to make this kind of like a devlog kind of thing. So let's turn the board on. It'll be in a waiting state. Now I'll write my bit stream to it. It's already prepared so that we wouldn't have to wait. The process is quite slow. Now you can see the blue LED. That's a heartbeat. On every positive edge, it blinks. Clock is very low for now. That's intentional. And there's also this popping up here. Up there, there's a 3.5 millimeter jack, mono output. I have headphones connected to it, and I'm not sure if you can hear it, but there's this popping. So I have this set up as a heartbeat, both visual and auditory. Now we have these switches here, as you can see, right? These 3 control reading to the 8 registers. These 3 control writing. And the last 2 here control both the power status of all the LEDs and the ability to write, global write switch or toggle, whatever you want to call it. So we'll turn on the global LED power. Now we'll turn on writing. And now all of these switches are at the 0 position, are low, turned off. So let's try, for example, and that would be register 0. We might as well start there. So now if I try pressing, you can see LEDs light up. This is binary, so you can think of it like this 0th position, 1, 2, 3, 4, in an inverse order. Like this is where it starts and that's where it goes. And so right now we would have the number 7. You can see that this is 1, this is 2, this is 4, because this is the position that adds 1, this is the position that adds 2, and that is the position that adds 4. If you sum them up, you have 7. So that's the status right now. Now we can switch to another register. Let me just open the schematic real quick. All right. So now we see register 0. Now let's do 1. So if I flip this, they go off because now we're reading register 1. So let's try writing to it. And you can see that we can't do it. And actually I think register 0 is bugged. Oh no, it's not bugged. Never mind. No, it's not bugged. All of our switches were at 0. So register 0 writing was enabled since the global, as you can see here, the global write is enabled. These are just selectors effectively. So now you can see that this switch is on. So now we're reading register 1. Remember, it's binary, the triads. We have 8 registers, right? So if you count 1, 2, 3, these are reads, and then 1, 2, 3, those are writes. So we enable 1, 2, 3, 4. We enable this one, and now we can write to it. As you can see, let's do. There are some timing issues. That's why it kind of like jumps at some point. Like when I press once, it kind of like sometimes jumps twice. Those are timing quirks, and it's a temporary issue, irrelevant to this. So as you can see, we have this value, right? Now we can flip this down. Now we can see that we only have 1, which should not be the case actually. We did have 7 there, which that is very strange. Okay, that was not expected. That was not supposed to happen. I think I found a bug. Okay, let's try writing to it again. So let's try getting 7 again. Let's turn this off, or on rather. Okay, now see we have 2 separate values. I don't know, there was probably a fluke or something. So register 0, this, register 1, this. Now we could do register 3. Well, let's do register 2 though first. Now you can see that there's 0 in there. So you can see 1, 2, 3. Again with this 1, 2, 3, 1, 2, 3. So here the middle one would need to be turned on so that we can write to it. All right, so now we can get, see, now the write can stay. We can turn this off. We can see the 3. We can turn this on, and we can see all these. So we can store values. We have 8 registers. And I can turn on off writing here, and I can turn this off. And let's try enabling all. So get to the last one, and now these are also on. These are just selectors. Now you can see that we can put a value here. Now I can disable the global writing here. Now you can see that I cannot add new values, or I cannot increment the value in the registers. Now I can turn it back on, and you can see that I can also do the global power off, and you can see that now none of them are on. So yeah, that's just a quick update. Very simple. You can store values in volatile memory currently, and that's the first step. And yeah, I'm gonna implement some moving between registers, so we'll be able to select a source or destination and then copy a value. So let's say we set the we set register 0 as the source, register 2, for example, as the destination, and we copy a value. So we'll just encode, we'll just, for example, set register 0 to 8. Then we'll copy the value to register, for example, 4. So first we'll encode using the switches register 0, increment to 8. Then we'll set the destination, and then we'll press one of the buttons, maybe the upper button, we'll see, as copy. That'll be like the move instruction, but in my eyes I decided to call it copy because on x86 MOV copies anyway. So I think it's kind of confusing that it actually copies when it's called move, right? So I decided to call it copy instead. And when you press it, it copies the value, and then we'll switch from displaying register 0 to displaying register whatever the destination was, 4 or whatever, and then it'll display the same value. So that's the next checkpoint, and you're gonna see that in the next clip. Bye.